Good day, everyone. I hope everyone's doing okay. Let's get started. It might take me a minute to pull everything up. I'm running behind in that department, but I won't be running real behind, I hope, in that department. So, pulling up your textbook here, going through the math. I'm going to assume you all are pretty familiar with PEMDAS. I'm not going to say a lot about PEMDAS, I hope not to. I'm going to assume you're familiar with absolute value and all that. The absolute value just makes a number positive if it's not already positive, and if it is positive, it just stays that way. All that stuff. Like E as in Edward here would be absolute value. We'll look at E as in Eddie here. You do PEMDAS, you go through all these steps here. Remember, please excuse my dear Aunt Sally. You do parentheses first or brackets or whatever. And you got to go inside and do the parentheses inside the parentheses. 6 minus 3 is 3. So that's done right here where my cursor is. You got to do, so you do that first. Then you go inside the parentheses here and you do the 4 squared next. There's the 16. Now, since 3 minus 16 is in parentheses, you do that, you get negative 13. Well, the next thing we can do is finally multiply. We can do the 7 times 15, you get the 105, and simultaneously we can do negative 2 times negative 13. Watch the signs, we get positive 26. And then finally, remember when we add and subtract, we go left or right, so we get 132. And remember with PEMDAS, parentheses has its own hierarchy. Exponents has its own hierarchy, second best. My dear, multiplication and division really have the same authority, and you go left to right to see who comes first. And then adding and subtracting have the lowest hierarchy. They have the same authority, and you go left to right to see who gets to go first. With PEMDAS, I have to sort of assume you know a little about this stuff. Now, D with fractions, it's always understood that the numerator is encapsulated in a pair of parentheses, the whole numerator, the right parenthesis in part D, in part D. Like there's a parenthesis around the 14, there's a left parenthesis to the immediate left of the 14, and there's a right parenthesis to the immediate right of the 2, and 3 times 2 there. And in the denominator, there's a set of parentheses separately around it. There's a parenthesis to the left of the 2 and 2 times 5. There's a parenthesis to the right of 3 squared. So there's coating in a fraction. There's a coating, like an aspirin coating around separately the numerator and separately the denominator. That's why you do the numerator separate and the denominator separate. So you go ahead and do your stuff in the numerator and your stuff in the denominator. 3 squared is 9 from PEMDAS. You go and do the 2 times 5 and the 3 times 2. You get separately, you get the 6 and the 10. And then you separately subtract because there's subliminal parentheses. You get 8 over 1, and 8 divided by 1 is 8 itself. Just little things like that. Now, absolute value, remember the absolute value of 5 minus 8, that's absolute value, neg 3. Now, this negative gets killed in the absolute value, but the outside negative does not die. So this negative comes straight down. This negative dies in the absolute value. So you have 6 minus 3, and then plus the product of 3 and 3. So that's 6 minus 3 plus 9, and that's 3 plus 9, and that's 12. So just watch out for the sneaky stuff. Now in PEMDAS, be careful about something with PEMDAS too, as well. There's subliminal parentheses, a parenthesis to the left of the 11 here inside the square root on part B. And there's a counteracting right parenthesis to the right of the 2. So there's parentheses surrounding 11 minus 2, in other words. So you do 11 minus 2 first, you get the 9. Then you do the square root of 9, which is pretty, that's 3. Then you do 5 squared, which is 25. And remember, there's an aspirin coating of parentheses around 25 minus 4, so it's 21. 21, now dividing is better than subtracting. 21 divided by 7 is 3. All a fraction is dividing. 3 minus 3 is 0. And that is that. And yeah, so sure. And well, and off we go. And just remember with square roots, if you have to deal with square roots, they can be aggravating. But there's a difference between Microsoft. Oh, we've not had to deal with it yet, but I guess I will now. Like if you have the square root of 11, be careful about something. The square root of 11 minus 2, well, if you put the minus 2 inside the square root like that, we know that that's just square root 9, and that's 3. But this is not, but that does not equal, but this is not the same as radical 11 minus square root 2. There's a big difference, right? Now, both of them are legit numbers, but they're not the same number, right? Square root 11 minus square root 2 does not give you radical 9. Indeed, and I should point out that radical 11 minus radical 2 is irrational. So let me point that out now. Radical 11, if you put the minus sign outside like that, it changes everything. Radical 2 minus rad 11 minus rad 2 is not even rational. It's actually irrational. It's the same. It means the same thing. So let me make my font a little easier to read. So go to Home, Font, 24, Home, Font. So there's that. Now, so indeed, radical 11 minus radical 2 is not even, it's not 3 at all. Because the minus sign's outside, right? Whereas the minus sign is inside here. And a little ditty, a little something I might want to caution you all on radicals. There's something kind of neat, though. There is a relationship, but it's not equality. Like if you did, well, like let's say that I put, let's say I put this in the bottom, and I don't have forever to play with this stuff. How would I rationalize this and simplify this? Y'all remember? It's probably been a minute. But what you do is you put parentheses around it, like a coding, but that doesn't really tell you how to simplify it, you know. But now what you do, there's an understood 1 up here, but what if it would have been something more interesting, like radical 5? Let's put something like radical 5 up there just to make it more interesting. So we just take radical 5, now radical 5 is just kind of there, you know. And now we do what's called the conjugate of the bottom. So by conjugation, we do radical 11 plus radical 2 down there. And we do it, I've made a ton of videos over this, and just see my videos I've already sent y'all, right? Why am I doing this again? But I've already sent y'all the videos. But you do the conjugation, right? And if it equaled 3, we this wouldn't jive. But anyway, you remember by we've already. I'm hoping I've already gone over. If you do FOIL distributive, radical 11 times radical 11 is 11, and the outer and inner terms cancel. Radical 11 times radical 2, positive. Well, that's positive radical 22. I'm off the screen here. So it's positive radical 22. No, sorry. Like that. And then that's outer. And you could do distributive if you wanted to. But then inner is minus radical 22. And last is negative positive. Neg rad 2, pos rad 2 is negative. Regular 2. Right, you know, you square root of 4 is 2. And then now up here, let's just let it be. We could distribute, but I'm going to let sleeping dogs lie. So we just get radical 11 plus radical 2. The numerator might not be pretty, right? We never promised anything much for the numerator. Now down here, we just get 11 minus 2 is 9. And up here, now we get something that's not pretty at all. And I told you not to expect it to be, right? I told you that no promises were to be made, right? That's radical 11 plus radical 2. And I need to get it on the screen. Sorry, here it is. So rad 5 parentheses. Oops, sorry, that's, well, I said it right, but I didn't type it right. So it's a rad 5 parentheses, rad 11 plus rad 2 divided by pretty 9. I wanted to get my denominator pretty. That's what I was after. Now that's good enough. You could stop there. We've rationalized the denominator, right? Or, so I started out with radical 5 over the difference of rad 11 and rad 2. And be careful, that is not radical 9 down there. Anyway, but we was able to clean it up after a long time. Now, or if you distribute rad 5 through, which if you don't want to let sleeping dogs lie and you want to sort of stir the pot, you remember that's going to be radical 5 times 11 is 55 minus radical 5 times 2 is 10, like that. Whichever tickles your fancy, and I'll highlight them both in whatever color, just to illustrate that we're done, say red. But we're done with either one of the red colorings there. But I'm just letting y'all know that, that's how you can divide by something that's kind of wonky, right? And rationalize the denominator. So there is a relationship between 9 and this other guy, but it's not equality, right? It's more convoluted than that. So yeah, I just want to give y'all a heads up about that. Now, if you have something more simplistic, if you just have something like a radical 3 divided by radical 7, now that would be radical, well, if the denominator is real nice like that, what you can do is, I've got 3 minutes to play with and I don't want to squander it. Control C, Control V. Now the numerator can be ugly, but all you got to do here is just multiply, well, the conjugate would technically be negative radical 7, but, that's kind of silly. We could just, we could technically, the conjugate of rad 7 is neg rad 7, but you're going to find that to be rather technically silly because those negatives are just going to kill each other anyway. Because the conjugate of 0 plus rad 7 is 0 minus rad 7. But these negatives, the reason why we can ignore them in this special case is because they kill each other anyway. Now, that's not true if we don't have the simplistic case, right? It's not, up there in that one we did earlier, we could not do that, right? But down here, we can do that. So, now, what happens here? That time sign's understood. Rad 7 is 7. Rad 3, rad 7. Now this time I'm all for it. There's no sense in not doing it. I don't want to let sleeping dogs lie. That's radical 21. We ought to do it, right? Yeah, radicals can do all sorts of pretty little things like that. They have these nice little things. And if the numerator was more convoluted, and I'm about to run out of time, let's say, but not, if you had something like a plus, not in there, an outside plus, mind you, SQRT plus square root of 2, well, you just do the same thing. That rad 7 would hit that square root of 2 as well. You'd have that square root of 2, and it would get hit by square root of 7. And you'd have radical 21 plus, now outside plus, mind you, outside, square root of 2 times 7 is 14, and there you go. Now, don't go putting radical 35 up there, right? You can't do that, right? Lest there be any mistake, for positive A and B, you can't add them, right? SQRT of A plus B can't be broken, right? Is not radical A plus radical B. I'm out of time. It's not. Thank y'all. Bye.